Okay, in this video we are going to look at polygon area problem solving. We're going to look at the area of complex figure guided practice if you have that with you. And we're going to look specifically at these three problems. The first two weren't too bad, but the third one is really good problem, and I want to take a look at that. So let's get into it. The first one's asking you to find the area of triangle MOQ, and you would need the area formula of a triangle, which is 1/2 base times height. Now, the problem here is that when you're dealing with grid paper, you need to have measurements be right on the grid lines. Diagonal lines you can't tell how long they are, especially when they're going through different boxes. They're not directly cutting boxes in half. It's very difficult to determine how long those lines are. So you want to use only lines that are on the grid. So to find the area of the triangle, you would need to find half the base and the height. Well, the problem is that this base is on a slanted line, so you don't know how long it is. Its perpendicular height is a slanted line, so you don't know how long it is, so you can't use that base height combo. And the same goes for the other sides. This is also a slanted line, so I don't know how long it is. Its height would be perpendicular to it. I don't know how long that is, so I can't use that. And then lastly, this line up here is also on a slanted line. I don't know how long it is, and then its perpendicular height, I don't know how long that would be either. So I have to go back to the drawing board. I have to do something different. So again, you want to use lines that are on the grid. And so I could notice that there is a rectangle here. RPNM is a big rectangle, right? And those lines are directly on the grid, so I could count how many units long they are. I also have a right triangle here, and I have another right triangle here, and I have another right triangle here. So I do have three right triangles whose measurements are right on the grid paper, so I could determine the area of that entire rectangle and then simply just subtract out those unshaded right triangles, and by doing that, the full area of that rectangle minus those unshaded triangles will leave me the leftover, which is the shaded triangle. So that's how you have to attack this problem here. So let's break it down. We'll first find the area of the rectangle. The formula, of course, is length times width. And then the long side of that, if you count how many boxes long it is, it's 10. And then it's 6 down from the top. So that would be 10 times 6. So the area of the full rectangle is 60 square units. So now I have to figure out the area of the triangles so that I could subtract them from 60 to figure out what's left over, and that would be the triangle I'm looking for. So let's start with this triangle up here in the corner. This is RQM. It's a right triangle. I'm going to use the half base times height, and of course I'm looking for that perpendicular side to identify the base and the height, which are those sides that are on the grid. So that would be a 5 by 6. It's 5 up top, and we already counted that it's 6 straight down for the side of that rectangle. So half of 5 times 6 is 15 units squared. Don't forget you're doing half of it since it's a triangle this time. And then this one over here, this is triangle, we'll call this triangle 2. Use same area formula, and the base and the height are also going to be identified with those perpendicular parts. That is a 5 by 2. 5 times 2 is 10. Half of that is 5 units squared. So that would be that triangle. And then this big right triangle at the bottom uses the same formula, and its base and the height would be determined also by the perpendicular parts. And it looks to be 4 on the one side, NO is 4 units long, and MN is of course 10 units long, so half of 10 times 4 is 20 units squared. So now I'm ready to put it all together. I know that the unshaded area, that would be the total area of the 3 unshaded triangles, would be 15 plus 5 plus 20, which is 40. So I'm going to take that away from the area of the full rectangle, and I get 20 units squared when I do that. So the leftover would be 20 units squared, which is the area of OQM or MOQ. Let's take a look at the next example. Now this one says that trapezoid ABDE is made up of a square and a triangle. And they give you the area of the triangle, and they're asking you, and they give you the length of CD, which is the base of that triangle. And the first part asks you to find the height of that triangle. So let's start with the fact that we're given the area of the triangle, and let's plug that into our area formula. So I know that the area was 60, and then I would do half of base times height. We know that the base is 12, and the height is the thing that we're trying to figure out. So now I'm just going to solve this equation. So I have half of 12 is 6, half of 12h is 6h, and then I'll just divide by 6, and I get that h is worth 10. So the height of that triangle is 10 inches. Now the second part says to find the area of trapezoid ABDE, which is the entire thing. Now you could use the trapezoid formula. Now that you know that the side length of that square is 10, you could just plug in 10 for the top and 10 for BC, and then the base would be 22 across the bottom. But I'm actually going to go about it a little bit differently. I'm going to highlight the fact that there is a square there, which of course I could just find the area of that square, and we were already given the area of the triangle, so I could just add those two things together. So that's how I'm going to do it. So the area of the square, we already figured out that the side of the square is 10. So 10 times 10 would be 100 square inches for the square. And then again, they already told me in the problem that the triangle's area was 60 units squared. So I'm just simply going to add those two things together to find the area of the trapezoid, and it ends up being 160 inches squared. Now, had you done the trapezoid formula, you would have had to do 10 plus 22, those are your two bases, and then times 10 and half of that. You'd have to use your trapezoid formula, but I thought this would be easier. Now the last one is the good one. The last one's the fun one. Now this is a pretty complex problem. This says the area of parallelogram ABEF is 84 square meters, and it's asking you to find the area of trapezoid CDEF. So first of all, what is trapezoid CDEF? Because it's not the entire trapezoid. The CDEF is this trapezoid here. If you trace it CDEF, those four points identify that that's a trapezoid. Now I can see that the bottom base, 8, so if you want to call that the bottom, the one on the left is 8, and the other one is not listed. But I'm going to start out with the trapezoid formula since that's what it's asking me to find. Hey, what's the area of this trapezoid? So if I plug in what I know at this point, well, I'm looking for the area. I know it's 1/2. So do I have, I know that the parallel sides are the bases. So I can see that 1 is 8, the one on the left. And then the other base would be that top part. Now, that number's not listed, EF or FE is not listed, but because if you remember the other shape, the ABEF is a parallelogram, that means I can actually, that's a parallelogram right there, I can just transfer that 5 down because opposite sides of a parallelogram are equal. So that means that EF or FE is 5 meters long, and that would be the other base. So I have my two bases to find the area of this trapezoid. I just need the height, which would be perpendicular to those two bases. Now that is not given. That's something that is not given, so it's unknown right now. So I don't have enough information to find the area of this trapezoid yet. I can simplify it a little bit more. I can add my two bases, 8 and 5 is 13. And I can even do half of 13 and get 6.5h. But until I find the height, I can't calculate the area of the trapezoid. So I'm going to go back and look at the information that was given earlier in the problem. It was given that the area of ABEF is 84 square meters. Now here's ABEF. And I used that fact that that was a parallelogram to transfer that 5 meters to that other side. But now I'm also going to use the fact that that area is 84 to help me figure out what the height is, because the height of that parallelogram is actually the same height as the trapezoid. So I'm going to use the area formula for an area formula for a parallelogram, which is base times height. And they tell me the area is 84. That was given in the problem. Now the base would be that 5, and the height, which is the perpendicular distance between those bases, that's the unknown, and that's the same height as the trapezoid. So I'm going to solve this equation by dividing 84 by 5 to get 16.8. So that would be the height of not just that parallelogram, but also the trapezoid that I'm looking for. So once I have that information, I'm ready to go. I just have to go and plug that into where I left off on my trapezoid formula. So back to trapezoid CDEF, I did all the work to simplify it. I just need to plug in the h now. So I'm going to plug in that 16.8 for h, multiply it by 6.5, and I get 109.2 square meters. So that one was a good one. If you got that on your own, And way to go. Hopefully you're feeling pretty good.